the end, so that is nice. Kind of the fact that one of them is labeled chapter 4 tells you that that's chapter 4. So the other one is more chapter 3. Okay. Acute trig. And chapter 4, when we get to chapter 4, it's just going to be one annoying piece that we are confronted with when we're dealing with obtuse triangles. But up until that point, you won't have to worry about it at all. I'll make sure all the triangles do not have that annoying piece when you're trying to work them out. Okay, because otherwise you're gonna get an error on your calculator. So those two booklets, have them on you the whole time. And this booklet, I would call it part 1. So because I think I'm gonna keep the same color for part 2, so you can just label that part 2. And so here we go. I want to remind you, I decided to put it right on the front cover. Round all your final answers to 2 decimals, okay? So that includes angles and sides. A lot of times students want to round angles to whole values, like a whole degree. Just keep it to 2 decimals as always, okay? All right. So let's get started. So we're going to start with the sine law. There's going to be sine law and cosine law. There's no tangent law if you're waiting for that one. Sine law, cosine law, those are the only 2 that we need to solve for any type of triangle. So if you recall SOHCAHTOA, right, that is only for right triangles, okay? So in IAPR, you learned about primary trig ratios, right? Sine, cosine, and tan. You also learned about sine inverse, cosine inverse, and tan inverse. So what would you need? What would you use the inverse operations for? Anybody remember? To find an angle. If you're trying to find an angle, you need to use the inverse, right? Maybe I'll write that down. Inverse. So if I ask you to find, you use the inverse of sine, that's what I mean, right? Sine with a little -1. It's not a power, guys. It's just the inverse operation. It's like multiplying has its inverse, which is dividing. Sine has its inverse, which is sine with a little -1. It does the opposite, okay? Primary trig ratios only work with right triangles. In grade 11 applied, you will learn to solve for oblique triangles as well, okay? So here it is, just a summary. Just draw a right triangle like this. Make sure the box is there. And this is a right triangle, obviously. That's when you would use, and every teacher does this slightly differently, but I taught it like this. SOHCAHTOA. I'm not saying don't, like SOHCAHTOA is not useful, but I tend to not mix them up. I'm going to stay away from SOHCAHTOA. I'm just not going to use it. You might, if you're in certain industries like plumbing, most of the time they use SOHCAHTOA still in plumbing, some trades, right? So then you have your acute triangles, right? They go like that. This would be an acute. And let's make one that is obtuse. So if they don't have a right angle anywhere in it, we call these oblique. Oblique triangles. So there's right triangles, that's a category on its own, and then you have oblique where you do not have it. It's like the opposite of a right triangle would be oblique triangles, okay? And we need, for this, we need sine law or cosine law, right? So you can kind of go off of that, right? So these two are oblique, and to solve oblique, we need to use sine law or cosine law. Okay. Remember that you will only be able to use one of the laws to get you started, okay? You will not be able to use both, only one of them. So I will teach you how to decide. Just like SOHCAHTOA, right? You have to figure out which one would I use, right? Same with, but now you're down to two choices, so it's actually easier. Okay? So here's the sine law, okay? This is brand new, but I'm gonna draw a triangle first. And I kind of make sure that it does not look like a right triangle. It is kind of, I make one side a little bit longer than the other. And we use capital letters for the angles or the vertices, right? And we use lowercase letters to label the sides that are across each angle. Okay, so lowercase and uppercase. We would refer to this as triangle ABC, of course, and this isn't new to you. I know that. I'm just being very clear. You know me, I'm sometimes overdoing it just to make sure you're all on the same page. So here's this is what the sine law says. If you were to take, it's called A, but any angle, if you take this angle right here, sine of angle A, and you divide it by the side that is across from it. See, you see angle A, side A. It's implied that they're across from each other. That will be exactly the same as taking sine of angle B and dividing it by the side across from it. And that will also be exactly the same as sine of angle C divided by the side across from it. And this is the format I will use to solve anything, okay, that involves the sine law. But it can also be flipped, where you have all the side lengths. So I will give you that just to, if you see that in a textbook, or if you see an answer key where I perhaps use this method, that it doesn't throw you off. You're going to get the same answer. So this is, in a nutshell, what the sine law is saying. And you're like, well, how is that useful for solving sides, right? Or angles? How is that useful? Well, that I'm going to show you how to do that. Us knowing this helps us a lot when dealing with any type of triangle. I will highlight this part here. Note sine law works with both right and oblique triangles, okay? So you could use sine law for a right triangle. It would still get you the exact same answer as if you were to use SOHCAHTOA. So why use SOHCAHTOA, right? Like it just doesn't make, I don't like to mix it up. So here it is. Let's just test that law, see if that's actually true. This is drawn to scale, okay? If you're ever interested, geogebra.com. You can draw anything you want to scale. And so let's try that. So let's take this angle here, sine of 22.7 degrees over the side length across from it, which is 3.74, okay, equals, let's take this angle here, sine of 101.39 degrees over the side length across from it. And now let's take that third angle, 55.9 degrees over the side length across from it, which is 8.03. Okay. Before I move on, this is very important because some students just blindly trust their answers every time. Largest angle right here is this one, right? It has to have the longest side across from it, or else you made a mistake, right? You got to go back to the drawing board, right? The longest side is across the largest angle. So let's divide this. Grab your calculator. I'm going to clear my screen. I want to make sure that you are set to the right settings before we even get started. So press mode and make sure this is not set to radians, okay? You need to go over to degree and hit enter so that the degree is highlighted, or else your answers are going to be way off. In grade 12, you use radians, so some of your calculators may be set to radians. So make sure that's set to degrees, and everything else should be fine, right? So just normal float degree. Okay? Then quit that, and let's just make sure you know how to use this, right? Sine of 22.7, put that in brackets like that. You need to close the bracket, it will automatically start, right? Divided by 3.74. That is 0.1032. I'm just going to round to 4 decimals. Okay? Let's do the same thing with the middle here. Sine of 101.39 divided by 9.51. You get 0.1031. So it's a little bit off, right? It's a little bit off, but that's okay. And then one more. Sine of 55.9. Close the brackets. Make sure you close the brackets. Otherwise, it may not give you the right answer. And that's 0.1031. Except for this one right here, we can clearly tell that this actually checks out. Okay, this checks out. This sine law checks out. So, sorry, they're all equal to each other, except for that one. You just got to close your eyes a little bit on that one. But if we rounded to 3 decimals, perhaps, then we would have been closer, right? But yeah, so sine law works. Okay, so I just wanted you to see it firsthand before you just blindly trust me. Okay, let's go and apply this. For the sine law to work, you need at least one pair. That is I'm going to use that a lot. The one pair. Sine law, for that to work, you need one pair. What does that mean? It means that you need a known side and the angle opposite to it. You need to see that I have a side and the angle opposite to it is given to me. It works in the following cases. So here you're going to have to do a little bit of, let me just see. Here. Angle side. What does that mean? Well, if you just draw a triangle like this and start anywhere. I'm going to start here. So let's say that angle is given and another one here is given and a side that falls. So if you start from the left, angle, side, that's when you use sine law. So what's this? This is the pair that I'm talking about. You have a pair. I should use this. This is a nice one. Yeah, sticks out. Right, you have a pair. So, all right, what's the next one? The next one is angle, side, angle. Okay, so let's draw, you can draw the same triangle if you want. And if you start on the left, angle, the side that bridges to the other angles, that's angle, side, angle. Do you see a pair? No, this is a hidden pair. See what I'm saying up here? When you're given two angles, right? When you're given two angles, find a third one before you continue. That's what I mean by that. And I will make a note here. Hidden pair. One second, guys. I want this to stick out. So hidden pair. This is the couple that hasn't announced it yet, right? They're not even holding hands, right? That's right. Find third angle, right? Sorry, angle. And then you use the sum of triangles is equal to 180 degrees. I would just say this, in general, okay? In general, if you have two angles, find the third one right away. And so now that is a check mark, and so you can say that you have a pair there. So if you're like, I'm stuck, you have two angles. Look at this. This one has two angles, AA, right? This one has two angles, AA. Just find the third one, and you are guaranteed to see the pair at that point. And then this other one is side-side angle. You could spell it the other way, but then I get in trouble, right? And so we're just going to leave it like that. Some of you are getting it, some of you aren't. It's going to take a while. And so you just grab any two sides, right? Side and another side right there, and that angle. Only one angle is given, but you still see the pair. This one, right? Two angles, just one angle. But right? And the check marks are there to represent a number. Like there would be a number there, a number there, a number there. Just look for the pair. Maybe some mental math questions I will ask you for this. Other than that, on a test, I will not really. It's like, I might ask you, what are the three cases where you would want to use sine law, right? These are the cases. Okay. Okay. Recall, this should help you determine if your answer is reasonable. Largest angle is across the longest side. And smallest angle is across the shortest side. And you will see that this is going to be more crucial than you think. And that's why I take the time to put that in. Okay. Draw and label the following triangle. You need to be able to do this. So triangle doesn't have to be to scale. Okay, don't worry about it being to scale. So I actually tell my students, just draw your triangle. Make it look nice as you can. And it's already telling me that D, E, F are the corners. So I tend to start on the left side and I go clockwise. And right about now, you're hearing the voice of your middle junior high teacher saying counterclockwise, right? It doesn't matter. You'll still be okay if you go clockwise, counterclockwise. So DEF and then D, this is the 60-degree angle. You put that where it belongs. Side D is a cross angle D, so that should be 5.2. Angle typo. It was only a matter of time, right? Let's turn this into F. F is 50. It's right there. And side F is over here, 8.3. Okay. And by the way, in this case, you got two angles. And you could easily find angle E there. But I just wanted to quickly go over. You know how to draw this, okay? Now that I've introduced everything and we're ready to start solving for sides and or angles. Okay, follow me to page 4. So I will apply the sine law using, like, I'm going to first focus on finding sides, and then we're going to do angles in a little bit, okay? So at first it's going to be fun, but then word problems are going to start to creep in, right? And that's when you're going to have to make sure you know the basics so you're not struggling with using sine law as is, right? So here we go. Determine the length of side B. So you need to figure out, right? This is angle B. So they're basically asking me to solve for that side. I expect you to know which side that would be. Right? Then you look at your triangle. Remember, at one point you won't know sine law, cosine law. Right now, all you know is sine law, right? So obviously it's going to be sine law. But look at the pair. Do you see it? There it is. Okay. You don't need to do this as part of your work. I'm just going to do it for the first little bit to get us to kind of highlight that. So you know you're going to have to use sine law. Okay, use sine law. Because of that pair, you've identified, okay, it's sine law, it's not cosine law, it's going to be sine law. Okay, what else do I need? Okay, follow me here. In order to find side B, you need the angle that's across from it, right? So you need to, and I'm going to actually write that down. In order, right, to solve for B, I need the angle opposite to it. So angle B, right, you just go 180 minus, I have the 38 and I have the 62. And that adds up to, this is 100, so that'd be 80 degrees. Okay, so now I know that this is 80 degrees. I can actually write that in. I'm going to use a red pen or red marker, right? And now I can actually go ahead and solve it. So watch what I start with. Yeah, go ahead. Watch how I start. I use my pair. That's usually what I use to start. Sine of 62 over 4.5 is equal to, and on the other side, I'm going to have my unknown. So I'm going to use sine of 80, right? I'm going to place that up here, and then I'm going to have a letter as my placeholder for that side length. And you might think, Mr. Durson, didn't you have 3 pairs earlier? Yes, that's just to show that that's what the sine law is saying. But when I want to solve, I just want to have one known pair, and on the other side, I'll have partial information. Okay, so now, did I show you cross multiplying and dividing? I have a feeling in chapter 8 I did. So all you need to do is go to the side where the variable is, start with the known, right? And so you travel down and then up. So I need you to show me this part right here, 4.5 times sine of 80 divided by sine of 62. And I would like you to just type this in and see if you get the same thing that I'm getting. Okay? And so that's 5.02 that I'm getting. Is that what you're getting? I hope so. And we are in meters. And I'm just going to do a quick check. Does that make sense? I will just make this observation that a 62-degree angle has a side of 4.5 across from it. Therefore, an 80-degree should have a greater side length, and it does check out, right? This side length is longer than 4.5, so we're good to go. It's actually the longest side, right? So this was my first step, right? Then I set it up, and then I solve. Not too bad, right? So far, so good. Give that one a try. See if you could figure out side A. if you just want to do it on the margin for now and then wait for me to do it properly, go for it. That's why I left lots of space there. We won't use it all. Okay. I just want to, if you had to pick one of those three, side, side, angle, 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 side, angle, what would you call this one? So you're like, which way, Mr. Dirksen? Is it this way or is it this way? I just look at it this way. It's angle, side, angle. I kind of just bridge it like this. But don't worry about it too much. I won't ask you that on a test. Maybe, and some of you might say, well, if I go this way, it's angle, angle, side. You're still identifying that there's two angles, okay? So in this case, if I want to find side A, this is the side, right? So boom. I don't have a pair, okay? This is the hidden pair. Right, so just go ahead and find that third angle. Angle C is 180 minus 85 minus 30. Okay, so that would get me to 95 minus 30, 65. You would probably get a mark for that on a test, right? So you insert that 65 because it wasn't there at the beginning. And then you identify, okay, this is a pair, this is going to have to be done using sine law. Okay, so then you go here, sine of 65 degrees over 14.5 meters. And careful, which one am I going to use now? Because I want this side, you need the angle opposite to it. If you use 85, you're finding this side here. So this is, you caught that, right? Sine of 30 over A, okay? And then you cross multiply and divide like that. And I tend to write down this number first and multiply it, because that way I don't have to worry about my calculator possibly mixing up the 14.5 and the 30. But if you're careful with closing brackets, you should, what happened there? You should be fine. So 14.5 times 0.5, because I know that that's what sine of 30 is. Is that what you're getting? 8 meters? Okay. And I'm just so used to stating it in 2 decimals, I just go ahead and go 0.00. Okay. And that's it. Let me just check something on the next page. I want to maybe use this opportunity to solve a triangle. But we're going to keep going. You probably remember solving a triangle means solving all sides and all angles. That's what it's asking you to do. Okay? I think I'm going to use this page to do that. It's not that much more. In terms of difficulty, it's not that difficult, but watch here. Applying the sine law. Now we're dealing with angles. Using the inverse function, sine inverse. Okay, so this is going to be an extra step in there. So you got to be comfortable working with it. And I'm not giving you diagrams for this one. So we've got this information. Triangle XYZ has the following dimensions. Sketch it, then calculate the values of Z and Y. We're actually going to do it in that order. Okay. Otherwise, we run into problems. So for A here, just draw your triangle. Start here, X, Y, Z. Okay. I know that X, right, side X should be right across angle X. Okay. Side Z, which is 3 centimeters, should be right here. and angle X is 34 degrees, which is in my diagram, it's here. And I'll tell you something here. If you draw it differently, if you start X, Y, Z, or something like that, as long as the sides are where they belong and the angles are where they're supposed to go, you get marks. Like, I'm not going to take off if you do it slightly differently than me. Okay. All right. Sketch a triangle. Calculate values, angle Z and angle Y. Okay. So first of all, I will indicate. You're going to get a bit tired of this, but bear with me, that you have a pair. Because down the road, you're going to have to decide. Okay? So that means that I have to use sine law. And I'm in fact going to start with it already. Sine of 34 degrees over 6.2 centimeters. Okay? And I'm going to go equals. They're asking me to solve for angle Z here. So watch how this goes. The sine of angle Z. Please do not just put Z up here. That's a common mistake. Sine and the angle, they need to be glued together. You can't just have an angle show up out of nowhere when you're solving it like this. Okay? And then down here we have 3 centimeters, right? Because this angle that you're trying to find has a side length across from it of 3. So we set it up like that. So the start is exactly the same as before, but watch this. You cross multiply up and you divide going down. So you go sine of Z, sine of Z, not just Z. Are you following that part, right? I'm not just dropping it. That's what I see a lot of students do. It's sine of Z, this is my unknown, is equal to 3 times sine of 34 divided by 6.2. Okay. And I will allow you to do this. Right next to it, we're going to figure out what that is. That's actually a decimal. So watch what I'm doing here. Just go 3 times sine. If you can follow along, go for it. Right? Get one thing out of the way. So I multiply the 2, and then I divide my answer by 6.2. And we use up to 4 decimals. I prefer you using all decimals, but I'm going to do this 2705 ... So I'm going to just do that, indicating that I'm going to use all of the decimals. So sine Z is this in terms of work, me showing work, but if I compute all of this, it just boils down to this. And here's the final step. Angle Z is going to be equal to sine inverse of whatever I just got. And that's the answer. So now I need you to look up and just watch. If you want to use all decimals, which is my preference, I go second, I press second, right? And then sine. Go second sine, it calls the inverse. And then I go second negative, because that calls up answer. And by negative, I mean this button way down here, okay? Because then it's calling the answer, and I'm pretty sure you're all familiar with that. So that's 15.7D, right? Because that 8 bumps that to a 10, which bumps this to a 7. So that's 15.7D degrees. And I'm just going to check, does that make sense? It does, because an angle of 34 has a side of 6.2. And so therefore a shorter side should have a smaller angle across from it. So this checks out, okay? This is just saying that I checked it. And now last one is angle Y. And this is where you need to be smart, okay? Don't do the sine law again. Yes, you could, but I will just go angle-wise 180 minus the 34 degrees minus the 15.70 that I've just found. And I'm just going to use my calculator. So it's 130.3 or 0.30, doesn't really make a difference. So this is double I that we've done here, and this is I, right? So obviously this is an obtuse triangle. Okay, angle Y is greater than 90, therefore obtuse triangle. So sine law, now you know how to do both things. You know how to find an angle, but you also know how to find for a side length. Okay. Let's keep going a little bit here. Solve for side Y. Right? It's asking you to solve for side Y. So it's asking for this side right here. And watch what I'm going to do. I always go back to the original pair. I do not use, because follow me here. We have another pair now, right? Once we find Z, right, we have another pair, correct? Are you following that? Could you use that new pair? Yes. You could use Z like this as your pair. But if you made a mistake here, it's going to carry over, right? So I'd like to stick with the original pair. Okay? So stay with original pair. That's just my suggestion. So I'm going to go back to sine of 34 over 6.2 centimeters is equal to sine of, if I want side Y, I need to use angle Y as my angle on the other side. And so side Y, absolutely, you can just have the letter there. In fact, you don't want sine there. Okay? Cross multiply and divide. Sine of 130.3. And I did this on purpose. I wanted there to be an obtuse angle so you know it works with obtuse as well. Okay? And that's divided by sine of 34. So I'm going to show you. I tend to always do the top, then I hit equals, and then I go this divided by sine of 34. It's 8.46. 8.46 centimeters, right? So you got to know, if you're using the inverse, you're finding an angle, your answer should have a degree symbol, right? If you're just finding a side length, then just use the units that were given to you. And this is a note here, which is important, right? As you solve for missing sides and angles, you will be able to solve for the rest in multiple ways. Like you can go in different ways to solve for the rest. So it's up to you. As long as you show me the work, I will figure it out and you will get the marks. And from time to time, your answer might be slightly different by 0.01. That's okay, right? That is going to be okay. And you'll see how that it does appear multiple times. Calculate the perimeter of a triangle XYZ. I'm hoping you know that one. Sum of all sides, right? That's what perimeter is. In a word problem, it could be like what was the total distance traveled from between all three cities? Something like that. So you got to be able to do that. So I'm going to just go ahead and add it. 3 plus 6.2 plus 8.46. That is 9.2, 8.46, 1766 centimeters. That'd be the perimeter. And I will talk about area, not yet, a little bit later, because you need to find the height of that triangle before you do that. Okay. So I'm getting to, I think I still want to talk about finding the height. So before I do that, I've kind of made this a little, I want this to be a bit more interactive, like where you get a chance to practice it right away. So I have inserted multiple questions that I want you to try. So I'm going to ask you to go to, where's the extra notes part there? Go to page 8 for now. And I just want you to try those three, like A, B, and C on page 8. Just give that a try. And I'm telling you which side to calculate. It should be there. Unfortunately, none of them ask for angle. So I'm going to do that here. I'm going to introduce that. Go to C, and I want you to put a question mark. Oh no, not going to work. So we're just going to leave it like that. Just do A, B, and C. It's all sides. We'll do angles a little later. Page 8, okay? So let's see. I might not give you enough time to do all three of them, but I will start giving you the answers in a bit, okay? No point in suffering through it alone. All right. So you were doing one-step questions right now. One step is usually easy to solve. Like there's not much to do. Just find your pair, set it up, cross multiply and divide. You're done. But now I'm going to ask you to consider multi-step questions. I'm just going to say this right off the bat. When you think you're stuck, just start solving for something. Just like, I have no idea, like, I don't know how to get there, but I do know that I can do this, right? Maybe just get started and get closer, right, to your actual side or angle that you're trying to find. So sometimes it cannot be done in a single step, okay? Try to see what can be solved first, then solve for the other dimensions, okay? And remember, I don't know, I always, as I was working through it, I just thought, what are the most common mistakes? Forgetting that, oh, if I want this side, I need to use the angle across from that side, not the one that's closest to it, right? So those are common mistakes. So here we go. If I look at this triangle here, you should recognize that this angle here is across that side. So yes, absolutely. Sine law, right? Absolutely. We're good. Okay, so you've identified that that's the law you have to use to get started. What can I do? So you know what? I'm going to go step 1. Okay, I'm going to go sine of 103 degrees over 12.7. I've got that figured out. What can I do now? I made a mistake here. Can you change this to side R? Sorry, Q is already given, right? So why would you want to solve for that? But this is, let's put this here, R. This is my ultimate question mark. That's what the question is asking me to answer. And so at first glance, you're like, yeah, I've got my pair, I've set it up. But what's the only thing you can do right now as is? You have this side length. So the only thing that you can do is solve for angle Q. So let's go ahead and do that, right? So I'm going to go sine of angle Q over 9 inches. So I'm going to cross multiply and divide like this. So sine of Q is 9 times sine of 103 divided by 12.7. I'd like to have just next to it, figure that out so that it's there. Oh, should have had that bubble here. If you ever do this and your answer does not start with 0 point something, you're going to get an error. It's going to give you a math error. Watch this. I'm just going to add 1 to that and try to take the inverse of that. You will not be able to do it. So your answer has to start with a 0. I don't know if that will remind you as you go through your notes. And then if you go to, it doesn't like your answer. So I'm gonna try this again because I kind of. So that's what you're supposed to get. 6904, and that keeps going. If you round it to 4 decimals, you would have to write down 5, right? If you want to truncate it, then you need to round. But I'm using all. So I just go dot, dot, dot. So Q, or angle Q, is sine inverse of 0.6904 dot, dot, dot. So I go second sine, second answer, close the bracket, and it's 43 point, and this is when you round, right? 67 degrees. I'm going to underline that because that's not really my final answer. Okay. So step 1, I've got this now. This is I've got that. If I have 2 angles, I can now find angle R. So step 2, angle R, right? So I'm going to go angle R is 180 minus 103 minus 43.67. Sum of triangles equal to 180 is your best friend, okay, in this case. So that is what, 77 minus 43.67? That's 33.33. I made a mistake. Didn't I? No, because this is 77. Yeah, we're good. We're good. I'm going to underline that because it's important to me, right? Step 3, now you can solve for side R. Okay, now, only now can you actually go there because you know that this angle here, right, is across the side you want. I'm going to start with the same pair that I had right from the beginning. So I borrow that because that stays. And now I'm going to use sine of 33.33 over side R. And you cross multiply and divide. No inverse necessary here because you're not finding an angle. And let's see what this gives you. I left you so much room there. Isn't that nice? I learned my lesson from stats. Oh, it's sine 103. Sorry. That's what. Good catch. Good catch. Okay. Let's do this. $7.16, right? chances. That is the ultimate. That's the one you circle. That's the one the question was asking for. So it took us basically 3 steps to get there. So when you think you're stuck, right, chances are just keep solving for what you know you can solve and then fill in the rest. Okay. All right. Here. This is your homework. There's a little bit in the workbook and there's more in the textbook. I would say the workbook can be done fairly quickly. The textbook might have a little bit more 1 or 2 step questions. I'm going to stop here because I feel like you had enough. So let's just wait for the bell. If you want to start working on the workbook, I will post the answer key. Thank you, guys.